Hello, everyone. Our senior design project is a holographic type video conferencing system design. I'm Hongzhi, an assistant professor from the School of Computing. The objective of this project is to address the limitation of traditional video conferencing by developing a system that enables immersive, full-size 3D holographic conferencing. So as we know, existing video conferencing, it's just a 2D. Human beings are displayed as a flat two-dimensional visuals. It lacks steps, and there is a gap between real in-person meeting. This project is to replace this with realistic life-size hologram that create a sense of physical presence between remote participants. For example, as this picture shows, a user can interact with a virtual hologram. And this hologram is displayed as 3D, which means if you move around this hologram, you will see different view. It's not like a flat computer display, right? So no matter which direction you see, it's just the same. So 3D are different. So this would make the communication more natural and engaging, especially in emerging applications like education, telemedicine, and remote collaboration. So how can we implement this system? So here we will use RGBD camera array. So this RGBD camera, different from RGB, it can capture color and depth. So here we use 3 cameras. They form an array, they are synchronized, and they will capture different angle so that we will build a 3D point cloud. We create this 3D point cloud, and then we do segmentation. We will extract the user, the human being, and then we will do enhancement, use computer vision technology, especially deep learning. So the reconstructed 3D point cloud, it will be displayed using a mixed reality tool, the Microsoft HoloLens tool. So in this way, the user can see a 3D human being. So this will be interesting for computer vision and networking researchers. So first, we want to build this holographic type communication, and we can use it as a platform to benchmark several technology, including computer vision and networking. And second, let's consider like Zoom, this kind of video conferencing industry vendors. So they will be interested in immersive communication. And lastly, as an education tool, for example, if you don't want to attend a class, so you can sit in your apartment and we can capture your hologram and send it to a remote location, and we can use it for education. So you will not start from nothing. We already have a prototype. So here, as you can see, we have HoloLens, and we can use it to display point cloud. And we have this camera array, we can capture 3D point cloud, but the quality is not high. It's just a very sparse point cloud. So we want to enhance it using deep learning, use computer vision tools to make this point cloud with a high quality so that when we display it, it provides truly immersive experience. So it needs improvement. So basically this project is to make it from a very low quality rendering to a high quality rendering. So we will build a complete holographic conferencing prototype. That means we have one user sit around the RGBD camera array, and another user with HoloLens can see this 3D point cloud of the hologram in real time. So we want the communication to be low latency. So we can start from a wired system, and then gradually we will use Wi-Fi, and then later on we may try a remote location. And we will make this hologram life size. Then we will evaluate the latency, the quality, and the user experience in the end. So we want to limit the scope. It's not like we want to design a system that is more like a commercial product. So here we do not need to support the multi-user meeting, just a one-to-one. And there is no bandwidth optimization for constrained networks. So here we can do it on a wired system, and then we move to a wireless system. So here, at least we need to make this wired system work. So here we can include multimodal data. Besides this hologram, we can also add audio, and we can use GPU to accelerate. So we will optimize the system if once this system works. So the architecture, we will use RGBD camera with Python library to capture the point cloud, and then we will process it, use PyTorch, OpenCV, Open3D, and we'll have GPU workstation to process the data. Finally, we want low latency network protocol to stream the data. And the display will use Unity and the Universal Windows Platform app, and we will deploy the developed app in the Microsoft HoloLens 2. So we will provide you with this 3 RGBD camera, and we will provide the HoloLens and also a GPU computer. So mainly we will use Unity and Python development environment. So finally, you will develop the software and deploy the app in the Microsoft HoloLens. So the development environment, first we will use GPU for real-time processing, and we will use GitHub for the version control and collaboration. The tools we use include Unity, Visual Studio, so they will be used to develop the HoloLens 2 app. The programming language will be Python for the point cloud generation, processing enhancement, and deep learning enabled computer vision tools development. And the C# is used for the HoloLens 2 application development. So we will provide you with some examples, but as we mentioned, the quality so far is low, and you may need to modify and enhance the current performance. The deliverable will be the software for the 3D hologram generation and streaming, and then we need to demonstrate this holographic conferencing in Microsoft HoloLens 2. So we will meet weekly. There's no travel. We can also accommodate room meeting if necessary. So you can contact me using my email if you have any questions. Thanks for your attention.